Hi, it's Jan Beta, and we're going to continue the restoration of the Amiga 3000T today. I am going to replace all the electrolytic capacitors on the mainboard, and then we're going to see if that maybe fixes the slight sound issue that we encountered in the previous episode. And if it doesn't fix that, we're going to take a closer look at that and try to fix it. Okay, now that I have confirmed that the power supply is working again and the board is halfway working, I am inclined to replace the electrolytic capacitors on the board as well. I'm going to use Vishay capacitors for some of the actual capacitors that are on here. These are not easy to find in good quality from well-renowned brands anymore. Unfortunately, actual caps are not in production by a lot of good brand capacitor manufacturers. So Vishay is my go-to brand. They are still being made. For the regular radial caps, I'm going to use regular purpose Panasonic capacitors. All the caps are 105 degrees Celsius rated, which makes them last a bit longer generally. Except for the actual caps, the Vishay caps are only available, as far as I know, in 85 degrees Celsius ratings. The board layers, there's a ground layer and a voltage supply layer in the middle, sandwiched between the two outer layers, which have most of the connections between the components and such. The voltage layer and the ground layer are cut out in places where there's not supposed to be a connection. So even if we rip out through-hole plating or things like that, which I hope I can avoid, we're not going to short out ground to the voltage rails. In the best case, we're going to see how it goes. So yeah, I'm not going to talk much during this. I'm going to link a good capacitor list in the video description. One little nag I have with that list is that it lists all the capacitors as radial caps, which probably is fine to replace the actual capacitors with radial caps, but you're going to have to bend the leads over. So I went and ordered the Vishay capacitors. So it's electrically, of course, it doesn't make any difference replacing the actual capacitors with radial capacitors. They are going to work. They're going to do the same to the circuit. And as usual, I know there's people opposed to replacing working capacitors, but I am aiming to make this last for as long as it possibly can, and clean voltages on the board are a big part of that. And also, these might leak at some point in the future. They don't have an unlimited lifespan, these electrolytic capacitors. So I think it is a good idea to replace them at some point, especially in a rare machine like this, if you plan to use it and not put it in a museum or something. And as always, I'm going to go one capacitor at a time. Take my time, take pictures of the board beforehand so I don't get any polarities confused. Some of the ones I put in are going to be higher voltage rating, but the exact same capacitance rating is pretty essential for things like this, where some of these are probably relevant for timings. Some of them are just filtering the supply voltages, but you don't want to go too far off the original specifications. So that's what I do. I am probably going to mark these, so I have an idea which ones I already replaced. Except for these actual ones, I'm going to do those first, I think. I'm also going to mark the negative side, which is the side with the stripes, and then take pictures. So I can see from the pictures, or I can see better from the pictures, which side is supposed to be the negative side, and also which ones I already replaced. Because there's quite a few on here. You might hear some crows in the background, because I have a huge colony of crows nesting right in front of the window, basically. And it's springtime, so they are currently producing baby crows and are a bit more active than at other times. So apologies for that. You might hear the occasional seagull as well, and my air filter that I'm running while soldering. I'm not going to talk much about this process anyway, I think, but whenever I encounter something, I'm going to report back, of course. So let's do it. Okay, reporting back for the first time. This 100 microfarad capacitor, actual capacitor, actually doesn't seem to be original. This is a Panasonic cap, M for Matsushita. This is a 105 degrees Celsius, unlike all the other capacitors that were originally on here. Different from all the other brands. So I'm not sure if this got damaged at some point and replaced. And it also looks a bit corroded, so probably some of the battery leakage got in there from the expansion cards. Also looks a bit bulgy, so maybe this is not good anymore. I'm going to put that aside and measure that later with my ESR meter. Also, the pad looked a bit corroded, so I scraped off some of the solder mask from the trays next to it so it makes good contact. I'm going to just flow some solder over that. So this is supposed to go here. And it is. Okay, so this is ground. Yeah, these ones, 220 microfarad, going to be not so easy to get to, but I think we're going to manage. I am going to manage. Oh, and I'm always using fresh solder on the solder joints before I desolder them to make things a bit easier. And so far, it's going quite well, actually. So no problems getting these out. But this is just the beginning. We'll see how it goes. The ground connections on these are not easy to desolder, but I think I did a reasonable job. It looks pretty neat. Had to align these a bit. It's not going to make any difference functionally, but yeah, I wanted them to be kind of in the same position. I think that looks rather nice. Okay, now for the radial capacitors. These are hopefully going to be a bit easier. We'll see. Yeah, that's a lot easier. So I think about halfway done. Got this whole portion here and this. Things are progressing slowly because I'm taking good care to not damage anything. One thing that somebody suggested in the comments is to use low melt solder to get these out easier. And that actually works really well. So I'm super thankful for that comment. I don't remember who it was, but I think somebody from the A1K forums. So thanks for that tip. That makes things considerably easier. It's a bit messier because we have to clean up the low melt solder after using it, but it makes desoldering these, which are otherwise not so easy to get out, a whole lot easier. So that's a good tip. Just applying a small amount of low melt solder to these joints before you start desoldering. And this makes a bit of a mess, but yeah, getting these out is so much easier if you just lower the melting point of the old solder by adding some low melt solder. Yeah, that one's already loose. This works really well. And you need to clean up the remnants of the low melt solder thoroughly, because yeah, that makes a bit of a mess, of course, because it melts much quicker than your regular solder. So again, I learned something from your comments. Thank you for that. And maybe somebody who watches this video was wondering that all along. And yeah, I can confirm it works really well. And I'm totally going to use it for the rest of these. Yeah, I think I replaced all the electrolytic capacitors on this board. That took a while. I'm going to take a bit of a break and come back and test things. So fingers crossed this is still going to work and actually work better with the new capacitors. Okay, time to test the thing, or at least test if it still powers on and if anything gets hot or explodes. Fingers crossed. This was a lot of effort. I hope this board still does what it's supposed to do. Let's see. Widescreen, good sign. It actually still works graphics-wise. So it outputs a picture from the graphics chip and the kickstart seems to start up. And yay, we have our kickstart screen starting up here. So I should probably run some more tests on this and let it run for some time to see if anything gets hot or anything like that. Okay, let's hook up a GoTech or something that works and see if this actually does things. Okay, here's the current setup. I have my GoTech on top of the thing here now, and I'm running Amiga test kit. Still detects 18 megabytes total memory, 2 megabyte chip, 16 megabyte fast. That's good. We tested that before. I'm pretty sure it's still going to be alright. Let's check the CAA timers again. Yeah, seems to be okay. Let's boot up something else here. I think I have Tarikin on here as well. Okay, let's see if we get into the game from the GoTech. Yeah, this actually seems to work fine now. Both channels music are playing. I'm going to run the music test from the Amiga test kit again in a second, I think. Yeah, there's some graphics glitches, but I think that's just because this version of Tarikin is not a good cracked version. I have the original actually. Okay, I'm not going to get carried away, but Tarikin works. We had a wonky disk drive or a wonky disk. So let's start our Amiga test kit again. Okay, there we are. Let's do the sound test thing. Audio. Oh yeah, this is a newer version of this thing. Both channels are working. Okay. We still have the problem with the filter. Don't know if this is specific to the Amiga 3000T. Yeah, the low pass filter doesn't seem to work correctly. So maybe we have a broken sound chip in here or something. Interesting. So yeah, something is wrong here with the sound filter, the low pass filter. One channel cuts out. The LED works, so yeah, so if the LED is dim, both channels work. If the LED is lit up completely, the right channel doesn't work correctly. Yeah, we're going to have to look into that. Huh, interesting. Yeah, that went well, thankfully. We still have the issue with the sound though, so let's look into some schematics and try to understand what the problem might be. So here's the schematics for an Amiga 500 revision 6, I believe, audio filter circuitry, which is very similar on most Amigas, with the exception of the Amiga 3000T and maybe some other models higher up. This is a relatively simple circuit which centers around one LF347 op-amp. This is a quad input and output differential op-amp, and that is used in a way so that you get the negative waveform of the audio inputted from Paula here. That's the audio generation chip. Basically, you get the negative wave and the positive wave, and both are amplified separately. There are two channels, so we need, of course, separate inputs for two channels. Then basically audio gets in. There's a negative and a positive voltage supply rail. These are minus 12 and plus 12 volts in this case. I think this chip can take up to 30 volts or something like that. So it's a reasonable input, and that is going to be used to amplify our signals separately. And as you can see here, the right channel and the left channel are basically the same. It just printed out separately in this. Signals go in here, get amplified, and there's a little circuit here around a little transistor that is responsible for switching the filter. And if the filter is switched, that's a low pass filter to filter out high frequency noise basically. That's the plan. As we all know, the filter makes the sound muffled. It filters the high frequencies, so the sound sounds a bit more muffled than without the filter engaged. Yeah. When the filter is engaged, this is hooked up to the same address as the LED. And as it says here, when the LED is off, the filters are bypassed. That is a feature that many games use to make the soundtrack sound a bit more crisp, and it works really well. So this is, LED is off, filters are bypassed. The switching is done with this little transistor here. Yeah, there's two transistors, separate for left and right channel. And here you can also see the LED. And that signal that goes through a filter is then amplified by the same LF347 op-amp that is used for the initial amplification. So this signal goes through the same chip on here, and then gets through some more filtering and things like that, is just going out to the audio output RCA jacks on the Amiga 500. Now, on the Amiga 3000T, things look a tiny bit different. It's a very similar circuit, but this one has this here, which is an input for CD audio. So one of these LF347 chips is just used in the regular way, basically. But then all the channels on this, because we're talking a stereo signal, are used. So we would need three channels basically. So they put another quadruple op-amp in here, another LF347. And I think, if I interpret this correctly, that one is used to amplify the filtered signal. So that might be our culprit, or something somewhere before that. So this seems to work fine. Our signal is fine when the filters are bypassed. So the first LF347 probably is good. My money would be on this LF347, the second one that is used for the CD and for the filter output. I would check that at first, I think, because these things can break. I've seen that in a couple of Amigas. And also, we have our regular RCA jacks here, just like on the Amiga 500. But then, we have another little amplifier chip in here. Yet another amplifier. This is a LM386. That's a very standard, not very high quality amplifier chip. I think this is the one that people use for building cheap guitar amps and things like that as well. So this is a very, very basic amplifier chip that is used to power our speaker, which is connected here. We have an internal speaker in the Amiga 3000T. So this just takes the signal after this whole chain with the LF347 op-amp and outputs it amplified to a degree that can power a little speaker. So I think what I'm going to do is to check the inputs on this LF347 and see if the signal gets there, and then see if the signal comes out of that. So here's the same circuitry that we've just seen in the schematics. This is our Paula chip. There's our CD audio input, and this is the first LF347 that's used for amplifying the regular signal. And then we have the second LF347 over here that I think, if I understand the schematics correctly, is used for the CD input and for the filtered output. So I think what I'm going to do in order to test this is to get my oscilloscope started up, start Amiga test kit again, and output our sine wave and see if this chip might be broken, or maybe it's maybe I understood the schematics wrong and it's this chip that's responsible for that. In any case, we're going to kind of trace the sine wave and see where it is no longer transported, because we had no output basically when the filter was engaged. I have both channels when the low pass filter is off, and when the low pass filter is on, the right channel only outputs a very quiet signal. So that's definitely not right. Yeah. It's probably difficult to hear for you, but it's definitely a problem with the filter. So I'm going to leave the filter on here and let the signal pass through the board. I'm going to switch off the sound, but we're going to see the signal on the oscilloscope in a second. So this is the output of one of our channels on the first LF347. The general output should be on pin 1 for the left channel. Yeah, that's our output for the left channel. And the right channel goes in on pin 9 and 10. 9 and 10. And that's not coming through. That's supposed to come out of pin 8. Yeah, that looks a bit wonky compared to pin 1. Okay. Interesting. Let's look at the other chip. So yeah, this seems completely dead. Okay, let's see. Yeah, so we're not getting much here. What the heck? This is supposed to be our output. Yeah, something is clearly super wrong here. This is our input. That's 1/2 of the sine signal. And this is the other half. That's from the Paula. So Paula seems to be all right. Yeah, and then that goes into pin 9 and pin 13 on the first LF347. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's there. And then this should be 10, 11, 12, 13. That is the other signal from Paula. Yep, that's getting in there. And this should be output on pin 14 for the left channel. And on pin 8 for the right channel. That doesn't look right. These are our outputs. So it might just be the first one that's faulty. Or something pulls the signal low on the output. Let's check the voltage supply. So both of these should be getting 12 volts on both of the pins. Positive and negative voltage. This is minus 0.7. This is minus 12. So it doesn't get the plus 12. Okay. This one gets minus 12. Is the plus 12 volts rail broken, maybe? No, that's okay. On the power supply connector. So we're not getting voltage through there. That's not good. So something is wrong with the plus 12 supply to these LF347s, so they can't really do what they're supposed to do. And the plus 12 is okay on the power supply. That's 11.6, but that should be all right. So as these are differential amplifiers, they need a positive and a negative supply voltage, and that is usually plus and minus 12 volts on these. This is our plus 12, should be. And this is our minus 12, which is excellent. But our plus 12 is not coming through, while it is present on the power supply pins. So somewhere there is a break in the supply voltage, in the plus 12. So clearly our supply voltage, or positive supply voltage for the op amps, is not coming through, and it's not coming through as the supply voltage for the little LM386 amplifier either. So we are going to have to trace this back. This is 0.76 or 0.75, and basically the voltage should arrive at this little capacitor here. This is C409, that's between there. And we have the same there. And where does it break down? It might also be that our chip is bad. And that pulls something to ground. That our LF347 is bad. So there's not much in between our plus 12 and the positive voltage going into our LF347. This is our LF347. Yeah, this could be faulty, C409. This could be faulty. This is one of the caps we replaced. This could be faulty, and this resistor could be faulty. Going to check these components. Just going to follow the traces a bit more, I guess. The other components that I could reasonably measure in the vicinity here seem to be all right. Yeah, I looked up my particular problem here in a search engine, and it might just be that it is this chip. I found a forum post where a user had the exact same problem with the voltage going negative on the positive supply pin of the LF347 because the chip was completely gone. So that might very well be. I'm just going to try to desolder this chip and see if the voltage rail looks better without it, actually. And I'm using my new trick with the low melt solder. Let's see how that goes. Okay, that works really well. There we go. That wasn't too bad. Let's clean this up before we power this back on. This is what it looks like. Doesn't look half bad. Really, really quick with the low melt solder, even though this is a multi-layer board. So let's see if this changed anything with our voltage. If this was the culprit, it might be the other one, of course, or the LM386. These are both hooked up to the 12-volt rail. And both could be internally shorted and drag the voltage down. But dragging it down to a negative voltage, which is what we've seen, it's more likely that it's one of these differential op amps that use a negative voltage for the other. Yeah, you know where I'm getting at. So yeah, this might very well have been the culprit, and also backed by the fact that it completely stopped working, or the sound output completely stopped working once I poked around there with the oscilloscope. Maybe I gave it the rest. Yeah, let's see. Hooking it up to the power supply again. Power supply is back on. Let's see. Nope. We still got minus 12 and no plus 12. It got a bit better, basically. It's no longer minus 0.75 or thereabouts. It was what it was. It's now 0.69, so it definitely changed things for the better, but this is nowhere near the 12 volts we need. Going to trace this a bit further, I guess. Yeah, so it should be totally coming through. This is where it gets here, in this direction here. That's the positive of this capacitor here that I replaced. And it gets to here, and it also gets to the other LF347, and it also gets to the LM386. That's all on the same rail. Yeah, so I followed the 12-volt rail a bit, and it arrives at all these here, the expansion slots. So it's very close, but it doesn't arrive here. That is very bad. So it might just be, yeah, I'm not sure what that might be. There's not much in between, actually. So it originates here. These are the filter capacitors close to the connector. And these are fine. I have my 11.6 is what we get on this rail, but nothing here. Somewhere between here and here. Something's going wrong, I think. The connections seem to be all there, and the small components in the way, I mean, I measured them all in circuit, but nothing shorts out or anything like that. The transistors are okay. The capacitors I could find in the way are all right, but we still get a much too low voltage that's going into the negative. So maybe it's the LF347 that I suspected to be broken all along. That's connected to the same rail here, of course. And that rail is low. And it's actually good basically everywhere else. Maybe I'm just going to desolder the other op amp and see if that changes anything. A bit out of ideas. I mean, we don't have any sound at the moment, so things definitely got worse when I started poking around there. Yeah, that was easy again. So let's try. Okay, maybe that fixed our voltage rail. I don't have too high hopes at this point. It's 2.25 now. Okay. It's getting better. So something is still pulling that low, but I'm not sure what it is. It might be our LM386 here. Probably just going to pull that as well. Otherwise, the components look pretty good, actually. Yeah, I'm going to pull the LM386 as well. just to be sure. It's pretty easy to desolder stuff with the low melt solder, so why not? A bit out of ideas. Okay, works even better with flux. Okay, let's see if that did anything. Okay, that's our minus. And that's our plus. It was a shorted LM386 of all things. That little audio amplifier bugger. Ah, yeah. I was pretty sure it must have been one of the chips, but I didn't suspect, as you've witnessed, I didn't suspect that one at all. This was the culprit. Took me a while. I'm going to have to find a replacement for this. I'm not sure if I have one. We should have normal sound output with the LF347 spec in place. And I bought a bunch of those because I suspected it to be one of these. So we can try new ones. I'm going to put sockets in, I guess, so we can replace these in the future. And I think I might have an LM386 because it's such a common amplifier chip. I think I have some of those somewhere. We'll see. Going to put some sockets in here. That's the next step. What a nightmare. It's not that much of a nightmare, but could have been much easier if I just desoldered the LM386 first. But I didn't suspect that. Yeah, it's never too easy, not too easy to troubleshoot these things, as you've seen. But that doesn't explain why the filter, it did work initially, but the filter didn't work on one channel. So not sure what caused that. Probably one of the op amps, of the quad op amps, also was a bit faulty. Maybe there's something more. Chances are that this is just going to work again now. I'm going to put new op amps in there. I might as well just leave the LM386 out for the moment until I find one. Pretty sure I have some of those. I was planning to build one of those little guitar amps. So these are the ones I'm going to put in there, Texas Instruments. Hopefully that fixes our audio issue and gives us audio in the first place. Just making sure these are in the correct orientation. So there we go. Phew! Let's connect it up and test it. Okay, cross your fingers, everyone. Let's see if we still get anything here. Yep, that still works. Let's see if our audio is working. You don't get any audio. What's going on? Not sure if that's due to my cabling here or something. Huh. What's going on? Why don't we get audio? Maybe we need an LM386 in there to get audio at all, but that shouldn't have to do anything to do with anything. That clearly didn't work. Just going to put a 386 in there, I guess. Which I actually have quite a few of in my parts bin. So these should do the trick, I guess. We're going to see. Maybe I broke my Paula chip, or maybe something's wrong with my cable. Could be anything at this point, I'm not sure. I'm just going to run this again and see if we get anything there. Nope. No audio. Probably just going to hook up something directly from the amp. Maybe my cable just broke or something. Yeah, I hooked up my little amplifier to the sound output directly and we still don't get any sound. Might still be my amplifier. Maybe I'll check some voltages before I come to any conclusions here. That is really strange. I'm not sure what happened. I didn't do anything hilariously destructive, I don't think. Now we don't have any sound. That's worse than it was. A lot worse than it was. Yeah, let's see if we get the correct voltages on the chips now, at least. No! That's our minus 12. And that's supposed to be our plus 12. That's our minus 12. That's supposed to be our plus 12. These are new chips. Just going to pull them again. So this is without the LF chips. That's 2.2. That's not much better. Minus 12 is coming through fine. Let's pull the LM chip as well. And we should have some kind of sound output, I guess. At least. Yeah, that's a bit better. That's 10.5 without the LM chip. That's too weak. The whole rail is too weak. Now I get minus 7. What? What's going on? Now I get plus 10 with the filter on. With the filter off, I get minus 7. Where it's supposed to be 12. Plus 12. So something in the filter circuitry is playing tricks on me here. What the? Why? One of the transistors? Probably. Yeah, actually don't really know what that is. That's our voltage rail that's depending on our low-pass filter, it seems. Maybe one of the transistors broke. That's the only thing I can think of. Especially since it is depending on the low-pass filter, which it was all along, but we had sound initially. Now we don't have anything, so it must be, yeah, with the chips in place, there's not too much, there's not enough juice on that rail to power the chips, actually, or to power the amps in the chips. That's my theory, at least. If you have any ideas, let me know. So back to the drawing board, or the schematics. It might be this Q400, which is a 2N3906. That's responsible for the cutoff, and our plus AV, positive audio voltage, is connected to that. So if that shorts out, it is going to short our voltage out to ground, at least partially. And we also have another transistor here, Q440. That's an MPF 102. That might do something. That's also connected to the Q400 here. That might pull the voltage low. We also have 2N2222 close to the LM386 here, Q951 and Q952. And those are also connected to ground and to the positive voltage. We also have this resistor here, R913. Unfortunately, I don't have any of these transistor types in my parts bin, so I would have to order them. I think the most likely would be this one here, 2N3906, because it is connected to the cutoff, which is the filter, I think. So, yeah, maybe that is the thing that just shorted out and now prevents this from outputting any sound at all, basically. It might be something completely different, but that would be my idea at this point. Because it did work, And then I started poking around with the oscilloscope and nothing worked. Maybe Paula is broken. I'm going to check this Paula in a working board, I think. And I'm going to order some transistors. And yeah, I think that's probably it for this episode, because I don't have the necessary parts and I'm a bit out of ideas. That would be the last idea I have, and I can't really test it because I don't have the parts. Yeah, failure is always an option, I guess. It's worse than it was. Now we don't have any sound at all at this point. But I'm pretty sure it's one of the components I mentioned. As I said, I don't have them or replacements for them in my parts bin. So I'm going to have a few days of waiting until I can try this out. So I'm going to wrap up this episode with another cliffhanger type thing. If you have any ideas about the audio circuit, what it could be, or if you have encountered a similar fault, let me know in the comments. I'm a bit stumped at this point, unless it is the transistors. But yeah, can't test that. I could pull some of them, I think, from an Amiga 500 board or something like that, but I'd rather take a few days off working on the A3000T board and put it away and order some transistors and then come back with a fresh view and maybe some comments that are maybe helpful. I'm not sure. Not many people have these, so I'm not sure if you encountered anything like this. So yeah, that's it for today. Unfortunately, at least the recapping job went well, I think. I don't think any of the capacitors I put in there are causing this particular fault, because it was the exact same behavior that we had before recapping this previously, and now it's just silent. But yeah, you win some, you lose some. Thank you very much for your time. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are in the video description and on my website in case you want to give me some support. You make these videos possible, and without you, I am nothing. As the old Placebo album title goes. That's it for today. I'm Jan Peter. Thanks for watching. See you next time. Bye.